Welcome to episode 2, and this one's going to focus on testing a hypothesis. So we'll be using, again, Cornell style notes. If you need a refresher or if you've never been able to set them up correctly, please take a moment to look at the short video on how to set up Cornell style notes. It's on Blackboard in my course. So what you're going to learn during this episode is the different ways to test hypotheses, the types of data, distinguish between quantitative and qualitative data, forming conclusions, and finally what happens once you've completed your investigation. So when you're testing a hypothesis, you're just trying to see if your predictions are supported. The most common way people think of testing hypotheses would be designing an experiment, but there are some other ways. You could make a model, gather and evaluate evidence or research. So you could go online or go to the library or go talk to some people in first person and find out what's going on to find out whether you've predicted correctly or not. Or you could just collect data and record observations. So there's some different types of data. The first thing you need to know is that the empirical evidence is the name for what's gathered during a scientific investigation. Some people just use the word evidence. Specifically evidence, when you're talking about evidence in general, it's more like things like in language arts when you're citing text evidence, things like that. Empirical evidence is specifically for scientific investigations, and it's what you are required to collect during any investigation. Through that evidence, then you get the data. That's what you record, and that's what you use to analyze. The two types of data, one is quantitative, and that's just data in numerical form. So whether you're measuring something or counting it or weighing it somehow, if you're using numbers, it's quantitative. Anything else basically is going to be qualitative. So if you're not using numerical form, you're just being descriptive in some way, that's qualitative. So how do we distinguish between quantitative and qualitative data? It gets a little confusing sometimes, and we want to make that straight for you. So I thought we could use something you might be familiar with, the story of the three little pigs. So you got the three little pigs in the house there, and the wolf is trying to eat them. So what kind of data would be quantitative? Well, one would be that there's 3 pigs. You can count them, 1, 2, 3, that's numbers, 3 pigs. You've also got 3 houses. And you've got 1 wolf. He's over here in the corner, getting ready to eat the pigs. Now, that doesn't sound super sciencey. You could do other things like, the temperature, the weight of each pig, if you could actually weigh them, and maybe you could determine whether the pig's weight had something to do with it surviving or not. All those are different ways. The other type of data would be qualitative, and so that's describing things using not numbers. So one of the easiest things to describe here would be the materials used to build the house. You've got a straw house, a stick house, and you've got a brick house. And you could use that to describe the types of houses if you were doing some sort of wacky experiment on the story of the 3 little pigs. So now you're ready to kind of finalize everything. You've got your data analyzed, the relationships and trends have been found, maybe some inferences have been made. You can draw a conclusion. So a conclusion is just a summary of what you learned when you were testing the hypothesis. It's real important that we distinguish between a hypothesis being correct or supported. We never say in science a hypothesis is correct. It's more like a prediction is correct, but the hypothesis is either supported by the data or it's not supported. So if it's supported, scientists are going to retest the predictions anyways, just to make sure the conclusions are the same. So if you're flipping a penny and you flip the penny 5 times and you get heads 5 times, do you stop at that and say, I conclude that every time you flip a penny, you get heads. Well, no, that's kind of ridiculous. So you would keep flipping and you'd come up with some sort of ratio percentage. Maybe you could find out that heads are more likely. Maybe there's more metal on the side with the head, whatever the determining factors are. If the predictions are incorrect, then we say the hypothesis is not supported. Again, it's important to distinguish. We're not saying the hypothesis is wrong. The prediction is wrong, but the hypothesis is just not supported by what we did. So what would scientists do? Well, again, they're going to retest, but most likely they're going to alter the hypothesis just a bit and test again. And they'll do this numerous times. So in the case of the pigs, if they're doing some sort of experiment on their ability to survive in a house, maybe their hypothesis was that brick houses are the safest from wolves. So they built the 3 houses and put themselves in there as bait. And then we got the straw house. And the straw house, as we know, was blown away by the wolf, and the little piggy ran into the stick house. Maybe the stick house, at this point, maybe the stick house is stronger. And we know from the story that both those pigs, they did not survive in that. They had to run to the brick house. And then finally, the brick house was the one thing that kept the wolf out. So that supported the hypothesis that the brick house would be the safest. Finally, you got to share your results. You can't just, as a scientist, you can't just find something out and then be like, ooh, I'm going to keep it to myself. That's kind of like the cartoon version of a scientist, the mad scientist who creates evil things and just uses them to rule the world or become rich or whatever it is. They communicate results. Scientists do that often, and some of the ways they do that, they write science journal articles, speak at a conference. Going on the internet and sharing information right now is pretty much the biggest and most used way. And there's some other ways of exchanging information. Sometimes there's co-ops or sharing that goes on between scientific corporations, things like that. All right, so we've got the end coming, and we want to make sure that we learned everything we're supposed to. So we talked about different ways to test hypotheses, the type of data, quantitative versus qualitative, forming conclusions, and then what you do once an investigation is complete. All right, look forward to you in the next video.